Hello everyone. In today's video, I'm going to show you how to determine if a sequence converges or diverges. Okay, and I'll show you how to find the limit, because the limit is at the end of the day the one that helps us to determine whether the sequence converges or diverges. Okay, so look, as you can see from here, I have a sequence. A sub n is equal to 3 plus 5 n square over n plus 1. Okay, so the target is if this diverges or converges, to know if this diverges or converges. So before saying it diverges or converges, let's just remember something here. Okay, so the sequence a sub n, okay, the sequence a sub n has, this is very important as a background knowledge, has a limit. Okay, has a limit. Remember, this has a limit, and then the limit expression is gonna be like this: the limit, okay, the limit of s sub n, okay, as n approaches to infinity is equal to L. Okay, is equal to L. L is just a number. Okay, L is the number or the limit of that sequence. Okay, so if we find a number or a specific number as a limit, we can decide that limit or that sequence converges. Or if the limit is different than any specific number or real number, it can be infinity, for example, we say it diverges. Okay, it diverges. So keep that in mind, and then let's go to our problem. Okay, keep that in mind, and let's go to our problem. So as you can see from here, n plus 5 n squared over n plus 1. All right, so when you see something like this, the first thing that you have to do is you have to write it into limit expression, which is the limit of 3 plus 5 n squared over n plus 1 as n approaches to infinity. Okay, this is the first step to write with limit expression. Then the next one is, as you can see, n approaches to infinity. Do not substitute directly infinity and then try to find the limit. All you have to do is this: look at the denominator. Look at the denominator. If you see at the denominator here, the maximum or the highest exponent in n is just 1 in this case. Okay, in this case n is just the maximum exponent, but every time what you have to do is you have to look for the denominator, and then you pick the maximum or the highest exponent of uh, the n with highest exponent. But just now it's not a problem because only one n we have, but there is a time you can find a lot of n's, okay, together in the denominator. So during that time you pick the one with highest exponent. All right, so and then what you have to do is divide everything by that n with highest exponent. What does this mean? Practically, this is what it means. Okay, so this is gonna be the limit, of course, as n approaches to infinity of 3 plus 5 n squared divided by n, because n is the highest exponent in the denominator, over again n plus 1 again divided by n, because I said divide everything by the highest exponent in the denominator. Okay, so now the next is, let's see if we can simplify something. Okay, this will take me directly the limit, all right, as n approaches to infinity. Still I don't substitute my n yet. So 3 over n, okay, that's 3 over n. So if I plug in n in here, okay, this is gonna be, let's go one more step, 3 over n plus, okay, 5n squared over n is what? The one n will cancel with one n, and then I remain with just 5 n, okay, over, okay, because this n is for everybody in the numerator, for 3 and then for 5 plus n squared. And then the same thing is true for the bottom one. Okay, n over n is going to be 1, because this n divided by n is 1, plus 1 over n. Okay, 1 over n. Now this is the time to plug in my I cannot simplify more than this. This is the time to plug in my infinity. So for the first term, 3 over n, if I plug in n in the infinity in the n place, 3 over infinity, 3 over infinity is going to be 0. That's going to give me 0. And then let's next, 5n means 5 times infinity is, you know that this is basically big number infinity, over, now I have 1 here, okay, this one right here, and then plus 1 over n means 1 over infinity, okay? 1 over huge number that approach to 0, that's 0 basically. So then this is infinity over 1 basically. The top part is going to be infinity. The bottom part is, the limit of the bottom part is 1. So this is in general infinity. So look, compare now with this one. If you compare with this one, okay, with the first definition here, with the first background knowledge, it's not it's not a real number or a specific number. This is infinity. So I can conclude that now, hence, okay, I can say that, hence, all right, the series S sub n, okay, diverges, okay, it diverges, okay, it diverges as what? As n approaches to infinity, okay, as n goes bigger and bigger and bigger, the whole sequence diverges because my answer is infinity here, okay? So this is how you calculate or how you find the limit, and then based on that you determine or you decide the convergence and divergence. All right. Let's do another example. Okay, let's do another example to make it more clear. Okay, let's say the second question is number 2. Let's say number 2, and then let's see. Okay, n a sub n. Okay, my sequence is given as follows. Okay, given as follows. And the power of 4, okay, you can find it in different form. All you have to do is be careful about the denominator, okay? And the third minus, look at that now, it is n the third to n. See, now I have two n's in the denominator, but all I have to focus is the n the power of 3. That's the maximum. The n the power of 3 is the maximum exponent. Look at that. This is the maximum exponent in the denominator with n. So the first thing is, first thing first, what I have to do is I have to write this one in limit form, okay? In limit form. This is going to be limit expression. The limit, okay, the limit as n approaches to infinity of n the power of 4 over, okay, and the third over again, and the third minus 2n over and the third, okay, and the third, and the power of 3. Good. So this is now time to simplify. Time to simplify. What will happen? All right, this is still the limit, okay, as n approaches to infinity. Okay, you don't have to now and then write the limit approach to infinity as long as you know what you're doing. So n the power of 4 over n the power of 3 is gonna be what? Just n. Okay, the top part is just n. Okay, because this is 4, this is 3. 4 minus 3 is just 1. Okay, so that's n, only one n. And then look, the bottom one, n cube over n cube is going to be just 1 plus, okay, plus, sorry, that's minus. I don't know why I write just plus. This is minus. So this is minus what? Minus, okay, look at that. 2n over n cube, okay? 2n over n cube is 2 over n square, okay? The one n will go away and then I remain like this. Now I cannot further simplify this. This is the time to plug in my limit, which is this as n approaches to infinity. Okay, so if I plug in n for the top part, okay, the top part, the limit is going to be infinity because you plug in n at the limit of n as n approaches infinity is infinity. Okay, so okay, and then I just can finish it together. I can do part by part, but just the same. So minus 1 minus 2 over n square. I just have to plug in infinity at the denominator here, and if I plug in infinity, 2 over infinity is small number over huge number. You can understand it that way. So this is just 0. So this will give me infinity over 1 minus 0 is just 1. And then this is gonna be infinity again, infinity again. So again, hence, okay, as a conclusion, my sequence A sub n, okay, diverges, okay, diverges because this is infinity as what? As n approaches to infinity. So the sub n, A sub n, or my sequence diverges, okay, my sequence diverges, right? Let's do the third one, and then let's see what will happen again, okay? Number 3, the third question, okay? The third question is as follows, okay? So still we have a sequence A sub n, okay? My sequence is this, 3 times the square root of n, right? Over, and then square root of n plus 2, okay? As always, again, the rule is still the same as always. So look at the denominator. If you look at it in the denominator, there is square root of n, okay? Well, basically, square root of n means what? Square root of n means n the power of 1 over 2. I don't have any other n besides that one. So all I have to do is I divide everybody by square root of n. Okay, remember that. Always go to the denominator and look at the n, which one is the highest exponent. Pick that one and then divide everybody by that. So the next step can be, okay, I can write this one, the limit expression as n approaches to infinity of 3 root n, remember, over root n. Okay, root n was picked now. Okay, over root n plus 2 again root n, because that's the maximum or the highest exponent in the denominator to begin with. All right, so this is gonna give me this. Okay, now time to simplify. Okay, time to simplify. I can simplify this. I can simplify this one. Look, this will cancel with this one, so I remain with simply just number 3. So that is 3. All right, over, all right, over, look, that's 3 as n approaches to infinity. So this is gonna be what? Root n divided by root n is still 1 plus, and again 2 over root n is just 2 over root n. Okay, what will happen now? This one, okay, this is gonna be finally the limit, right? Okay, as n approaches to infinity of 3 over 1 plus 3 square root of n. I cannot simplify further. Okay, so this is enough. So the top one is as n approaches to infinity, the limit of L is just L, which is the limit of 3 is just 3. Okay, over, okay, so when you plug in n infinity, still in the denominator I will have 1 plus, if I plug in infinity here, 3 over infinity is almost 0, so that's gonna be 0. So this is gonna be 3, so the limit is 3. Now I get a different answer. This one converges. Okay, converges. It's not infinity this time. So that means, in conclusion, hence I would say hence my sequence a sub n converges. Okay, converges, right? Converges as n approaches to infinity, because I got a limit L. Okay, a limit L. And then remember, at the beginning we say the limit of that series. Okay, I mean that sequence, if the limit of that sequence is just a number L, we can say that is convergent or converges. Okay, that was for today. I hope you enjoyed this video, and next time I will see you with another video on other concepts. For today, have a nice time.